everyone. Let me introduce myself. My name is Yohana Adriana Warlela. My student ID number 201440047. Instrumentation 2A is my class. This afternoon, I'd like to explain about the control valve working principle. In principle, the control valve is the same as the manual valve. The difference is that the actuator usually uses air or fluid, media or same as a mechanical system, and motor to move the valve. The driving component is usually called the actuator. The actuator movement can be linear or rotating. Using it allows you to easily control the process of opening and closing the fluid automatically. Thus, you don't not have to be careful about closing or opening the valve manually while the valve is operating. I will talk more about the working principle of the control valve based on its type, control valve components, and function. First, I'd like to about control valve working principle based on its type. That is, the first, A2O or air to open, is a type of valve whose normal position is closed ANC or normally closed, and will open if supplied with the control valve itself. The air to open type works when the control valve gets a signal. The control valve will open. This type of air to open is a process when the pneumatic actuator and control valve are open if compressed air is supplied by the air compressor. And the second, ATC or air to close, is a valve whose normal position is closed and O are normally open and will be closed if supplied with the control valve itself. The air to close type works when the control valve gets a signal, the control will close. Now, I'd like to move on to the opening or closing of automatic control valves. The opening or closing of automatic control valve is usually done by electric, hydraulic, or pneumatic actuators. Normally with a modulating valve, which can be set to any position between through, open, and fluid closed. Valve positioners are used to ensure the valve attains the desired degree of opening. Air-actuated valves are commonly used because of their simplicity, as they only require a compressed air supply, whereas electric-operated valves require additional cabling and switch gear. And hydraulic-actuated valves require high pressure supply and return lineage for the hydraulic fluid. Next, let me describe the control valve components when viewed as a system. Consists of 1. Pneumatic air regulator. Function to adjust the supply of the pneumatic air to AP to rise 15 psi. 2. AP converter. Function to convert electric signal 4 mA until 20 mA from controller into pneumatic signal 3 psi until 15 psi. 3. Actuator. Serves to move the stem valve or valve cover rod according to the pneumatic signal coming from the AP. 4. Positioners. Serves to position the pressing of valve openings according to the centers of the control valve. I'd now like to turn to the types of control valve based on how it works. This type of control valve consists of gate valve, globe valve, valve, butterfly valve, check valve, and safety valve. 1. Gate valve. How the gate valve works is the handle is rotated. The bonnet moves up to the tube of the connector with the stopping weight area changed by forcing the movement to be up and down. The handles the raise and lower the stopping occupy the bonnet space. 2. Globe valve. Now, how it works globe valve is a valve that has a linear direction of motion and is designed as a stopping or stopping flow. Opening flow and regulator flow, the disc in the globe valve can shoot off a fluid flow. 3. Ball valve. Ball valves are widely used because of their ease of rapid and ability to withstand high pressure and temperatures. Depending on what material they are made, ball valves can withstand pressure of up to 10,000 psi and temperature of around 200 degrees Celsius. 4. Butterfly valve. Butterfly valve have a relatively simple construction. The main components of a butterfly valve are the body, sail, discs, and stem. A typical butterfly valve has a disc position in the center of the pipe. It is connected to a stem that connects to an actuator or handle on the postage of the valve. In the closed position, the disc is perpendicular to the flow, as shown in the figure, and is held by a valve seat. The stem is also closed using an O-ring. 5. Check valve. The way the check valve works is that when the flow is in its direction, the rate of the flow will pause, drop the disc or plug. While if there is an opposing flow, the plug will be closed. So there will be no big flow into the pipe. 6. Safety valves. How the safety valve works. The valve opening is very fast, 60% opening immediately if there is excess pressure. The safety valve will close again if the pressure received by the valve is below normal pressure or normalized. Finally, let me explain control valve function. In this case, the control valve used is in certain place which often call it a surge gate. As we often hear during a flood, the flood gate also functions as a flood controller to regulator the often heard during a flood. The amount of water that flows into the river. There are several functions of the control valve, either manually or automatically. This valve can manually close or open the control the flow by human power. However, currently many control valves are equipped with electric, pneumatic, or hydraulic components. In the flow with a large capacity and high pressure, this is commonplace. In conclusion, I have explained the working principle of the control valve based on its type. A2O or air to open and ATC or air to close. Control valve components and their function. If you want to become an instrument expert in a good control process, the working principle of a control valve might be one of the materials you need to understand. Here's my presentation, and thank you.